Hello, welcome you all to my video lecture on interfacing 7-segment display. In this session, we get introduced with the 7-segment displays, their types, writing hex codes, for example from numbers 0 to 9, and interfacing of the 7-segment displays with 8051. In this we are going to see the hardware connections and then writing a program to display 0 to 9 on 7-segment display using 8051 microcontroller. So first, knowing about the 7-segment displays. 7-segment displays are most commonly used output peripheral devices. They are used to display numbers from 0 to 9 and alphabets A to F. So 7-segment displays are made up of either LEDs or LCDs. These LEDs are used to display the required numeral or a alphabet. So this diagram is going to tell you how do a 7-segment display looks like, and this is what the pinout diagram of it. It consists of 10 pins. 8 pins, they are connected to the LEDs, and the 2 pins in middle, they are internally shorted, and we have got the dot. And now when you see the top view of it, the top view of it shows you the 8 segments A, B, C, D, E, F, G and the dot point P. For example, if I want to display 4.5, so the decimal point is represented with this dot. Now going into the types of 7-segment displays. Depending on either the common pin is cathode or anode, we have two types: common anode type and common cathode type. In common anode, see here, in common anode, all anodes of the LEDs, all anodes are connected to common terminal and cathodes are connected to the port pins. Usually the cathodes are connected through the current limiting resistors. The purpose of the current limiting resistors and how we calculate the value of the resistance is explained in my previous videos. Now here if you go for the common anode, if you want to glow the LED, we need to give the cathodes logic 0. If you give the cathodes logic 0, so already the anodes are connected at plus 5 volts, and if you are giving 0 volts, see here, the cathode is at 0 volts, anode is at higher potential, that is plus 5 volts. So hence the LED will be getting forward biased. Once the LED gets forward biased, it turns on or it glows. So always remember, in common anode, if you want the LED to be on, turn on or the glowing, you need to give 0 volts, logic 0. And going with the common cathode type, in this type, cathode is common for all the LEDs and anode terminal is connected to the port pins. Again, anode terminal is connected to the port pins through the current limiting resistors. And here if you want to glow the LED, you need to connect the anodes to logic 1. So logic 1 is nothing but plus 5 volts. You need to connect it to logic 1 plus 5 volts and cathode already it grounded. See here, the anode is at 5 volts, cathode is grounded, so hence the anode is at higher potential than the cathode. Your LED will be forward biased and hence it turns on. Now considering common cathode. So whenever we want to write the hex codes, we need to know whether it is a common anode or common cathode. So considering a common cathode, we try to write the hex codes from digit 0 to digit 9. So we all know that this is what a 7 segment display: A, B, C, D, E, F, G, and here we have a dot. And now see the first column, 0. So digit 0 has to be displayed. So if you see here, A, B, C, D, E, F. A, B, C, D, E, F are to be ones. Only G is to be 0, because this is how we display the 0. Except G and the dot point. All others are ones. So what is the hex value we get? 0, 0, 1, 1, 3 and 1, 1, 1, 1, F. Similarly, you can go with another example for digit 1. For digit 1, we need to display these two, B and C. Only B and C. See here, only B and C are ones, all else others are zeros. So what is the hex code you are getting? 0, 0, 1, 1, 0, which is here 6. So this is how we write the hex codes from digit 0 to digit 9. So after writing the hex codes, then we'll understand the interfacing diagram. This diagram gives you the clear picture of interfacing 7 segment display to 8051. Here we have taken common cathode 7 segment display, which is connected to port 1 through the current limiting resistors R3, R4, R5, 6, 7, 8, 9, 10. R3 to R10 are current limiting resistors. S3 is the reset switch. R2, C3 forms a debouncing circuitry, whereas C1, C2 and the crystal are related to the clock circuit. VCC ground and EA external axis. Now we start writing the program. So origin 0, 0, 0, 0. Start the origin. Now see here the codes. So already we have taken from the table 3F, 0, 6, 5B, 4F, 6, 6, 60, 7D, 0, 7, 7F, 6, 7, so on. So these I store it in a lookup table. And how many are these? 1, 2, 0 to 9. So we have 10. So we are initializing a counter. Move R2, 10D. The D indicates decimal number. Move DPTR, hash code. So where we are storing the codes. So the memory location of it will be updated in the, or will be initialized in the data pointer register. So these two lines are initialization. One counter and the second one, it stores the starting memory location where the codes, where the hex codes are being stored. Now we are taking the accumulator register, move A, hash 0, 0, initializing it 0, 0, and then move C. Move code A, @ A plus DPTR. What does A has? 0, 0. DPTR has the memory location, the starting of the memory location. So it is pointing to 3F. 0 plus DPTR anyhow, it is DPTR value. So it is pointing to 3F. The 3F value will be moved to the accumulator register. Again move P1, A. So what does A has now? A has the 3F, and that 3F is moved to port 1, and from the port 1, so once it is given to the port 1, it will be sent to the 7 segment display. We all know that the 7 segment display is connected to the port 1. L call delay. Here we are calling the delay program, and this delay may vary depending upon the specification of the 7 segment displays. Then increment DPTR. So once you increment the DPTR, what happens? It goes for the next memory location. It points to the 06, and decrement the counter. If the counter is 0, then it has to come out of the loop. Decrement DJNZ, decrement and jump on no 0. If a counter R2 is not 0, then it goes back. It has to jump back. Again, A is 0 0, and already DPTR is incremented, so it is pointing to the 06. 06 will be moved to the port 1, and again a delay program. Delay is called. Again we are incrementing the DPTR, decrementing the counter. So the same set of lines will be executed 10 times. So because our codes are 10, we have to display 0 to 9. As per the requirement of the program, 0 to 9 numbers are to be displayed. So each time the DPTR will be pointing to the next code. So on it will be all the codes will be moved to the accumulator register, and from the accumulator register to the port 1, and they will be displayed on the 7 segment display. And now coming to the delay program. This is what the delay program. So here origin 0070, we started with this location. So delay, move R1 comma 02 decimal again, move R0 250 decimal value, immediate number, decrement and jump on no 0 R0 comma B1. So this instruction, each time the R0 will be decremented by 1, and until R0 becomes 0, it will be in this loop, in between these two lines. And once R0 becomes 0, it comes out of it, and now R1 is anyhow 0 2. So what happens? 2 times the external loop will be executed, and then it will be returned to the main program. So whenever it is an L call delay, this entire delay program will be executed by the microcontroller. So with this, we have seen the 7 segment displays, their types, writing the hex codes, interfacing to 8051, and also writing a assembly language program. Thank you all.